I'm just a little boy, though my story is seldom told. I have squandered my resistance. Hi, welcome back to the channel. I'm Zubin, and in today's video, we're going to talk about whether or not you actually need to learn data structures and algorithms to be a programmer. And if you stick around to the end, I'll give you some tips and suggestions on when it's a good time to do it and why it would be a good time to do it. But it's not always the right thing for you. So let's get into it.
Hello there! Welcome to my channel. Listen, after more than 12 years as a lawyer, I tried to start my own company. It was a startup and I was a non-technical founder. Sure, we managed to get a product to market, but you know what? I had a horrible time finding technical co-founders. In fact, I found a couple, but they ended up leaving. I was so sick of it. At the age of 37, I finally taught myself to code. But man, it wasn't easy. A year or so later, I ended up joining a startup as an engineer. And a year after that, I joined Google as an engineer. So listen, if you want to transition your career into tech, or you want to become your own technical co-founder, subscribe to my channel.
Right, so to begin with, let me first tell you that these are my views only. This is not some sort of official view of any textbook or anything. This is just based on my lived experience, and this is what I truly believe. That's one. Secondly, if you're already a computer science major or someone with some sort of computer science background or a couple of years of programming background, this video is probably not going to be that useful for you. So you may want to just skip it altogether and go check out one of my other videos. However, if you're a self-taught coder that's just looking for your first job, or you're a self-taught coder, or someone who's teaching yourself to code still and you're still in the process of learning the basics of programming, or even if you're just someone who wants to be your own technical co-founder, learn enough code for you to get your little startup idea off the ground, well then this video is for you, because it's really for people who don't have a background in coding yet. Alright, that said, let's get started. So let's start with what are data structures. Now this can be a very scary term to people. Data structures and algorithms is traditionally quite a scary concept to a lot of people, but I really think we make too much a big deal out of it. So data structures, quite simply, are So let's understand first what we mean by data structures. Now this can be quite a scary concept to a lot of people, so let's try to make it really simple. A list, for example, is a data structure. Why? It holds and organizes data. If you're a Pythonista, you may know something called a dict or a dictionary. In other languages, that's often referred to as a hash map or a map, or in JavaScript, it's just an object, right? So an object will have key value pairs. Now that is a simple example of a data structure. Some people even argue that a string is basically a data structure. Ultimately, a data structure is something that holds and organizes information so that you can then do operations on it. That's all a data structure is. Now, of course, the more advanced you get, the more you combine data structures. For example, for those of you who are familiar with object-oriented programming, or you know what, even if you're not, there can be composite data structures, more complex data structures, where you combine existing data structures. For example, you may create an object that has a property that is a string. It has another property that is a hash map or an object or a dictionary or whatever it is that you're using. And it may have a third property that's an array. Now that object has three types of data in it: strings, arrays, and hash maps or objects or dictionaries. And so that entire thing is also a data structure, but it's a composite data structure because it's made up of two or more other data structures. So that's all a data structure is. It's a way to collect and organize information or data in a program so that you can work with that data. Now, let's go to the next one, algorithms. Again, fancy word, but all it really means is a kind of recipe or a series of steps that you use as a formula almost in order to solve a problem. And typically, the more complex the problems are, the more you break down those steps into little bitty pieces, and each one of those steps may also be a smaller algorithm. So for example, a simple algorithm would be, how do you bake a cake? Right? You just had to put all these ingredients, then you have to, mix them in a certain way, then you have to bake them at a certain temperature depending on the kind of oven you have, etc., etc., etc. So it's a recipe. Similarly, in other languages, whether they're computer languages or other subjects and disciplines like other types of sciences, ultimately an algorithm is just a series of steps that you follow in order to solve a problem. But figuring out the correct algorithm is where a lot of the challenge is. Anyway, now that we've got the basics of algorithms and data structures, let's dive deep and analyze when and why we need them. So why would these be good skills to have? Why would it be worthwhile learning data structures and algorithms? Well, for one, it makes playing the guitar a lot easier. Did I disappoint you? Leave a bad taste in your mouth? No, but seriously, why would you want to learn these skills? Well, in general, for simple problems, we don't really need complex data structures and algorithms. For example, if I'm writing a little server on my computer at home, or I'm writing a little piece of code or a small little web page that only my friends and my family will see, you know what? The basic JavaScript objects will probably work just fine. A simple algorithm will probably work just fine because processors work fairly quickly. No problems. So you could say that for small scale computing projects or small little personal projects or even small business products that don't have a lot of users, a lot of traffic, a lot of sort of demand on the processing or the compute power, well, you don't really need particularly complicated algorithms and data structures because chances are you're not going to have problems of scale. You really get to need and appreciate algorithms and data structures when you're working generally on very complex projects or projects that have a ton of users or a lot of demand on the system. Now, I don't know whether many of you are familiar with Mark Zuckerberg's childhood, but apparently his dad was a dentist, I think, and when he was a kid or a teenager, he wrote a little program for the use by the Zuckerberg family in their house and his dad's dental practice. And really that program would have had maybe 6, maybe 10 users across the house, and it was on their own network and all the rest of that. Now, I don't know because I wasn't there, but I would argue that chances are Mark Zuckerberg didn't really engineer fancy algorithms and data structures to run that little home project of his because it had 10 users locally. However, when he did Facebook, again, maybe not in the early versions, but as Facebook started to grow and it started to get millions upon millions of users, suddenly the need for really strong algorithms and solid data structures to enable those algorithms to work swiftly would have become important. And so that's why you tend to want algorithms and data structures, is because you're solving problems of a certain size, at a certain scale, with a certain level of complexity, such that your computing resources need to be optimized. So that then brings me to the next point. What is the next point? So what is the next point? Well, the next point is, do all programmers need to know data structures and algorithms? I would argue that a better way of asking that question is, can you be a good programmer without knowing algorithms and data structures? And I'm sure what I'm going to say is going to be very popular on the internet. I'm sure haters are not going to have anything to say about this. But I really believe that there can be lots of good programmers out there who just aren't good at data structures and algorithms, and perhaps they don't need to be. So, a lot of front-end developers or even server-side developers don't really need to know fancy algorithms and data structures. In fact, there are lots of job interviews out there that don't test for those skills necessarily because, frankly, it's much more important that you know SQL with Django or whatever it is that that business needs, rather than knowing really sophisticated and complicated algorithms and data structures. Now, later on in this video, I will cover what sort of companies typically would want people with skills, with data structures and algorithms, and how you prepare for that. But that's for later. For now, the question is, can you be a good programmer without knowing data structures and algorithms? I'm sure all the people who are experts in data structures and algorithms will say, no, you can't. And I'm pretty sure you'll find lots of other engineers who are very good at what they do who aren't that great at data structures and algorithms. So you don't need to know data structures and algorithms to be a good programmer. However, I also see the argument that you could be a better programmer by knowing algorithms and data structures. But to be honest, everyone can be a better programmer, full stop. They can always learn new skills. But the flip side is not true, that if you don't know data structures and algorithms, therefore you're a bad programmer. I don't think that's actually true in all cases at all. Also, if you're not planning to be a professional programmer, maybe you don't need algorithms and data structures. If you're teaching yourself to code right now and you're still working on your programming fundamentals, I would actually argue that you shouldn't be spending your time on data structures and algorithms beyond understanding the basics of the data structures that come with your language. So JavaScript has arrays and objects, understand how to use them and the relative benefits and how to use them. But beyond that, I would say when you're learning to code and you're starting out programming, getting stuck into data structures and algorithms is probably a recipe for more pain than it's worth when you're self-taught. It's a completely different matter if you're in a boot camp and they're teaching you, or you're a computer science major or something like that. Also, I guess I would say that people who are learning to code in order to start their own startup, to be their own technical co-founder, which is how I got into coding, I would say they probably shouldn't waste too much time on it at all. In fact, I'd say just steer clear of it. You're much better off focusing on achieving your business objectives through code than trying to be the best programmer you can. So all this leads us to the question of, well, when should I bother to learn data structures and algorithms? And my answer to that is perhaps when your job actually needs it, or it's a specific goal you have because it's in service of another larger goal, typically a job. Generally, I would say that if you're starting out programming, or if you're a fairly junior programmer looking for your first job, don't bother to learn data structures and algorithms. Now, I know a lot of people are going to jump down my throat and say, that's rubbish advice, Zubin, you're full of shit, you don't know what you're talking about. Hey, that's your opinion, that's fine. My opinion is that you don't need it. In fact, I didn't end up needing data structures and algorithms knowledge for my first role. In fact, I didn't have that knowledge. For the first 1 year that I was a developer, it is much more important that I understood Node, Postgres, React, JavaScript fundamentals, HTML, and CSS than it was for me to know data structures and algorithms. I did not have to solve problems that required an advanced understanding of data structures and algorithms. Instead, I had to produce features for the front end and the back end and write code that was production ready and worked and got the business objectives met. So to summarize that point, unless your job needs it, your current goal needs it, or your career plan for your next job or 2 jobs down the line, you're planning your career, well, maybe then you may need data structures and algorithms depending on what your plan is. A lot of people assume that it's just part of becoming a programmer, and I do not agree with that. Sure, it could help you be a better programmer, but by no means is it necessary, and it's also not sufficient in and of itself. You could be an expert at lead code, you could be a competitive programmer, but if you don't know how to wire together a server and a backend database, it's not really going to help that you're a competitive programmer. Which then brings us to the next logical point. Well, how do I know it's part of my career goals, or when should I start preparing data structures and algorithms? Well, to really answer that, you need to understand what sort of companies value that. And that's a very research-dependent thing. So we know that all the big FANG companies like Google, where I work, or Microsoft or Amazon, all these big companies definitely do test you in advanced problem solving using data structures and algorithms. We know that. But probably because of that, because all these big companies do that, a lot of people assume you need it across the board. And that is a false assumption. My direct experience was that I chose not to do data structures and algorithms because I realized my first level goal to get an entry-level developer job when I was changing careers didn't actually need them. I did the research, I looked at how companies were recruiting at that time in Australia, and I said, how many of these people actually need data structures and algorithms? And I can tell you what, I've interviewed with American companies as well that don't require algorithms and data structures as part of their recruitment process. Now, some people out there, perhaps the elitists, perhaps people who have a strong opinion about this, may tell you that if it's a really good company and they have a really good engineering team, they're going to want people with data structures and algorithms experience. I don't know. I don't know that anyone can actually say that authoritatively. The point is, if you're learning to code, if you're teaching yourself to code, you're starting out, why make it harder for yourself than it has to be? It's much better for you to look at companies that don't necessarily need that, but actually value your fundamental language skills or the frameworks, like if you're a Django expert or a React or a Node or whatever it is, or Java. Go for companies that test you on your ability to use the tools that they use every day, not necessarily over-indexing on your advanced problem-solving skills. That's something you can develop over time. If I tried to add on the burden of advanced data structures and algorithms at the time when I was learning to code and looking for my first job, I probably would have felt really overwhelmed. As it is, I was quite overwhelmed. And remember, you can get paid to learn. Get that job, keep developing your skills as an engineer, and study at night, study on the weekends for your next job. Which then brings me kind of to my last point. We know that big tech companies or even smaller tech companies that have potentially large audience bases or large system needs, global scale, for example, are likely to test on data structures and algorithms. So should you be pursuing these companies as your first job? Is this the right target for you when you're learning to code or when you're fresh out of a boot camp? I know it's possible, and I know some people have done it, and I would argue that you can always try for it. But my personal advice and my personal suggestion to you based on my direct experience is it's better to give yourself a success in the form of any first job that is good enough to pay your bills, to keep paying you to continue to learn. Because don't forget, your first job is not likely to be your last job, okay? So you want to get into the industry, you want to develop experience, you want to get your CV or your resume to show that you actually have industry experience, that someone else paid you to be a professional developer. That's much more important than it is to join the big companies and the elite companies to start with. Aiming that high is a good thing, but it also means that you end up having to put a huge amount of effort, can get overwhelmed, you may decide to give up, and your odds of success are smaller because the competition is so high. So you may actually find that a lot of good jobs don't actually require you to do data structures and algorithms. Why wouldn't you just go for those jobs to start with, get solid industry experience, get your resume to show that someone else is actually giving you a job as a professional engineer, and actually build your own confidence from within the industry, build your learning from within the industry, be paid to learn more code, right? When you're teaching yourself to code, you want to get to a job as fast as you can, as efficiently as you can, which means you want to learn only what's necessary. And this is something I spend a great deal of time on with my coaching students, is to help them understand what it is that they actually need to learn to land their first job. By all means, after that, pursue the big companies. For your second or your third job, go for it. But you might as well take 2 or 3 years of preparing for those companies while working full-time so that you can at least say, hey, I'm a mid-level developer and I've got 3 years of experience. That's worth a lot in the market.